Okay, so before we proceed with problem solving, let us first review the basics of derivative and integration. How do you derive and how do you integrate yung may minus and then yung may plus. Okay? So, unahin natin. Let's have an example. F of x is equal to 2. So, if we get the derivative of a constant, this becomes 0. Right? Ang derivative ng constant ay 0. Next, let's have another function, 2x squared. So, the derivative of this function is 4x. Okay? So, we're just reviewing, okay? Next, f of x is 2x cubed plus 4x. Okay? So, the first derivative is 3 times 2 is 6x squared plus 4. Okay? So, you have the following function. So, hopefully, you remember this kasi napakadali lang naman nito. Next, let's have integration. So, halimbawa, yung function na 2 gusto natin i-integrate dito. So, dito ang pag-integrate mo siya in terms of x, f of x. So, pag integrate natin yan, magiging siyang 2x plus c. Okay? Remember that in the integration, you always have a constant value. Kasi if we are undoing something, pwedeng in terms of derivation, yung paggawa natin, yung pag-derive natin, meron dong constant na hindi natin sure kung merong value or wala. Okay? So, ganun yun. I think you remember this naman. Next, let's use this 4x naman. Gamitin natin itong 4x. Tingnan natin kung babalik natin siya. This is 4x. So, meron kang 1 plus 1 over 1 plus 1. This is 4x squared over 2. Simplify. 2x squared plus c. Okay, so do not forget the value of plus c kasi kailangan na kailangan yon. So, bumalik pa rin siya sa dati niyang value. Let's try this one naman. Ang derivative naman, integral naman. 6x squared plus 4. So, you have 6x 2 plus 1 over 2 plus 1. Pinapakita ko na lang yung long cut plus 4x plus c. So, this becomes 6x cubed over 3 plus 4x plus c. So, this becomes 2x cubed plus 4x plus c. So, itong value na to, parehas pa rin yung lumabas dito. So, this is the basics of derivation and integration. So, I hope you remember this kasi, syempre, I assume that nakapasa na kayong calculus. You know this already. Okay? So, let's have the first sample problem. Okay, for this first sample problem, ayaw mag-next. Okay, a car's position is described with the following polynomial for 10 seconds. X of t is equal to t cubed minus 15t squared plus 54t. So, sinabi dyan, this is a car's position. Okay, so basically, this is a position function. So, sa part na to, if you remember the previous lessons that we have, you have your distance or position graph, velocity graph, and then acceleration graph. For this part, you'll be identifying what kind of function is it. Is it a position function, a velocity function, or an acceleration function? So here, it's mentioned already that this is a car's position. So generally, this is a position function or a distance function or displacement function, whatever you want to call it. Pero ang sabi dito, this is a position function. Now, if you can observe, we're going to use Desmos. If we use Desmos, you can see that the graph is technically not a uniform motion kasi nga, it's a function or a position function. So, you won't be expecting a straight line here. So, here is a better view of the function that we have. You can see it's a curved graph, so we cannot use, of course, x sub 2 y sub 2 minus y sub 1 over x sub 2 minus x sub 1, etc., etc. Okay? So, ito yung overview niya. But don't worry, you will no longer be using Desmos to graph this one because kahit yung function na given na lang na meron tayo, doon na tayo magsisolve nun. So, here, in the problem solving, you're actually asked for 8 questions. In one specific problems, you will be asked for 8 questions. But these are very, very easy questions kasi isa-substitute mo lang naman yung mga values na meron ka. So, for us to not be overwhelmed about these questions, let us first focus on 2 questions. The first question is the car's velocity as a function of time and then the car's acceleration as a function of time. So, let us remember that this is a position function, so the first derivative of a position function is your velocity, while the second derivative of the position function is your acceleration, or generally, the derivative of a velocity is your acceleration. So it's very important to first get the velocity before you get the acceleration. Kasi kung mali ka sa velocity, obviously, you'll be getting a wrong answer in your acceleration. So let's first answer this one. What is the car's velocity as a function of time? So you have x of t is equal to t cubed minus 15t squared plus 54t. We have to get the derivative. Okay? Kasi first velocity nga siya. So first velocity. Velocity of the car. So x prime of t is 3t squared minus 30, 15 times 2 is 30t plus 54. Ayan. That's very, very easy. Yan na po ang answer natin for number 1. The car's velocity as a function of time is this value right here. Okay? So, if you see in your reading material, tinanong sa inyo na, can we undo this to check kung tama yung answer natin? Of course, you can undo this. If we get the integral, kung kukuha natin yung integral natin, so, this will be x of t, which is just 3t cubed over 3 minus 30t squared over 2 plus 54t plus c. Or, let's simplify, t cubed minus 15t squared plus 54t plus c. So, you can see that the antiderivative of the velocity function is still correct. Okay? Sir, nasan dito yung plus c? Wala tayong problema kasi kailangan lang talaga natin lagyan ng plus c in this values. Kasi kahit mag-derivative, in x prime of t natin na may plus c, mawawala lang naman na siya. So, you just have to know that it's a must to write plus c kasi di natin sure pwedeng may value siya or wala. Okay? Kasi there are times that you'll be asked for, you'll be given the velocity and then you're going to look for the position and then the other way around. So, you can see that this is the value. At the same time, this x prime of t can also be written as v of t. Okay, v of t. Kasi velocity function na siya. 3t squared minus 30t plus 54. Okay? So, this is your answer for number 1. Very, very easy, right? So, dalawa yung nagawa natin. We were able to get the velocity function, which is this one. And then, we're able to undo to check our answers if it's correct. Kasi the area under, the derivative is your velocity, right? While your antiderivative of velocity is your function. So, nabalik natin siya sa previous na itsura niya. So, that's the first question. Next, let's have the second question. What is the car's acceleration as a function of time? So, remember, we already have the value. Let me just write down the value. Yung x prime of t and then yung v of t natin kanina. This is just the same, right? Yung nakuha nating value is 3t squared minus 30t plus 54. This is your velocity function. So, we are now asked to look for the acceleration function. Now, the acceleration is the derivative of the velocity function or the second derivative of the position function. So, we can just say that the acceleration function is the first derivative of the velocity and the second derivative of your position function. Halos pare-pares lang naman po yung ibig sabihin nitong notion na ito. So, either way, you can write it better. Pero mas maganda kung ganito na yung i-focus natin para hindi kayo mahirapan. Okay? But this one is just to show you kung saan siya galing and kung paano mo siya sinusolve. So, let's get the derivative of the velocity function. You have 60 minus 30. So, this will be your acceleration function. O, diba? Napakadali lang yan. We already have the second answer. So, to check, same thing that we did a while ago, if we get the integral of this value, kasi you know that this is your acceleration function, if we get the integral of this one, this should go back to your velocity function. So, check natin. You have, a of t is equal to 60 minus 30. So, kinuha mo na siya ng integral. This becomes v of t, 6t squared over 2 minus 30t plus c. So, this becomes 3t squared minus 30t plus c. So, this is your velocity function from the antiderivative of the acceleration function. Still, the same answer. Okay? When you undo something, should go back to the function na meron ka. Kasi parang ladder nga yung nangyayari dito. So, you can see we already did we already got two answers here, the acceleration, and then na-check natin kung tama pa rin siya. So, very easy yung number 1 and number 2. So, the functions in the problem, you have again, this is your position function. Position function, this is your velocity function, and then this is your acceleration function. Okay, so yung tatlong function na to, or these three functions in the problem, will actually help you answer the rest of the given problems that we have. Remember, we have 8 questions na answer na natin yung dalawa, so we are left with 6. So, napakadali lang naman yan kasi nakuha mo na yung tatlong basic functions. If you are not able to get these 3 functions, you won't be able to solve the rest of the problems. Okay? So, going back to this one, we're able to answer number 1 and then number 3. Now, we are left with 2, 4, 5, 6, 7, and 8. Now, I've mentioned that these 3 functions are very important in identifying the problem because as you can see, number 2, it's asking for the displacement. Number 4, the position of the car. Number 5, car's acceleration. Number 6, car's velocity. Number 7, average velocity and average acceleration. Now, all of these things are already defined previously in our discussions, but para lang ma-refresh kayo, when we say instantaneous velocity, that's the velocity at a given time, the velocity at that specific instant. Okay, so instantaneous velocity nga siya. For average velocity, displacement divided by the time. So you can see here, displacement siya divided by the time because it's d sub 2 minus d sub 1 over t sub 2 minus t sub 1. So your average velocity. Your displacement is just the initial final minus initial position. Your average velocity is change of v over change of t, while your instantaneous acceleration is just the specific instant in time obtained using the same process discussed in instantaneous velocity. Now, don't worry, this is very, very, very easy. Okay? Huwag kayong mamroblema kasi these are just terms, but if you try to understand it, instantaneous velocity at an instant, this is average acceleration, I'm sorry. Average acceleration is still average. Your displacement is just the initial, final to initial, and instantaneous acceleration, same thing. So, as you can see on the upper, upper right of the screen, you can see the 3 functions, blue, green, and then red, para mas madali natin siyang ma-determine. The first question is, where is the car? This is the first question. What is the displacement of the car? So, unahin natin yung discussion ng displacement of the car. Let's first identify the definition of displacement. Displacement is the final minus initial, right? And then, if you remember the question, it says that the time is from 0 to 10 seconds. So, from 0 seconds to 10 seconds, yan yung movement ng car natin or yung the movement of the car. So, the first question is, what is the displacement of the car? In your reading material, you can already see there that displacement is given by the change in x, where the x of time 2 is subtracted by x of the time 1 that we have. Okay? So, looking into the 3 different functions that we have, alin dyan ang meron, makaka-answer sa'yo na may displacement? Yung position ba, yung velocity, or acceleration? Obviously, since you're looking for displacement, it's in meters, you're going to use the first one, which is your position time graph. Kasi nga ni position. So, substituting all the values that we have, let's use green for the first one. You have t cube minus 15t squared plus 54t, yan yung first natin, subtracted by the value of t sub 1, which is still t cube minus 15t squared plus 54t. So, let's input the values. Dito is t sub 1 is 0, 0 cube, minus 15 raised to 0 squared, plus 54 times 0. Okay? And then, the initial value is 10 raised to 3 minus 15 times 10 raised to 2 plus 54 times 10. Okay? So if we get the value, if you input this in your calculator, you should be getting a value of the change in x is 40 meters. The displacement of the car is 40 meters. Sir, dito, kailangan ko pa ba itong isolve? Diyan, actually, 0 na to. So, ito na lang yung kukunin mong value dito. The value that you'll be getting is 40 meters. So, the displacement of the car from 0 to 10 seconds is 40 meters. As you can see, remember, very crucial or it's crucial to solve the different functions first before getting into the other problem. So, it's very, very easy, di ba? Nakuha mo na yung displacement ng car natin. Next. Fourth question, where is the car at 3 seconds? Okay, the question is where, so nasaan daw yung car at 3 seconds. Let's go back again to the three functions that we have, the distance or position function, velocity function, and acceleration function. Ang tinatanong where, alin dyan yung makaka-answer ng where? The position function. So we'll be using x of t is equal to t cubed minus 15t squared plus 54t. So, the time is 3 seconds. So, this is 3 seconds. Ayan, lagay natin. So, 3 cube minus 15, 3 squared plus 54 times 3. So, input in your calculators, you should be getting a value of the car. The value of the position of the car is at 54 meters. So, double check using your calculators. So, this is where the car is at 3 seconds. Okay, at 3 seconds. 3 seconds, the car is 54 meters away from its initial position. Okay, so very easy lang naman yung second and fourth problem. Fifth problem, what is the car's acceleration at 4 seconds? So the question is acceleration. Let's again look at the three functions that we have. Which among this will actually show you the acceleration of the car? So, syempre, ang may acceleration lang naman dyan, yung may acceleration function natin. So, a of t is equal to 6t minus 30. So, let's input the values. You have 4 seconds. 6 times 4 minus 30. So, this becomes 24 minus 30. So, your acceleration is negative 6 meters per second squared. Okay? So, this is the acceleration at t is equal to 4 seconds. We can say that during 4 seconds, the car is decelerating. Okay? Unlike in your graphical analysis, pwede ka lang tumingin sa graph. Pero dito, because of the values that you have, you can just conclude based on the quantitative value that you'll be getting. Now, you might be asking, sir, paano ko nalaman na yung unit mo is meter per second? Same with this one, paano ko nalaman na meter siya? Kasi po, yan yung basic units niya. Unit nito is meter, this is meter per second, and this is meter per second squared. So, don't forget that one. Unless, otherwise, it's stated on the problem. Pero, in this problems po, ganito lang naman yung kinukuha natin. Meters, meter per second, and then meter per second squared. So, this is the acceleration at 4 seconds. Actually, this question is your instantaneous acceleration. Kasi at 4 seconds yung tinatanong sa kanya. Number 6, what is the car's velocity at 4 seconds? So, same thing that we're going to do. Let's first look into the graph. Alin dyan yung mag-show sa iyo ng velocity at 4 seconds? Is it the position, the velocity, or acceleration? Obviously, your velocity function. So, v of t is equal to 3t squared minus 30t plus 54. So, if we try to input the values, v of 4, 3 times 4 squared minus 30 times 4 plus 54, you should be getting a value of negative 18 meters per second. Okay? So, this is the velocity at 4 seconds. Okay? So, dito po at 4 seconds, we can again say that the value is negative 18 meters per second. So, this can either be going to the opposite direction. Okay? Kasi, vector to, diba? Alright. Next is the average velocity and the average acceleration. Now, going back to the definition of average velocity, the average velocity or the v bar is just the change in x over the change in time. Now, the change in x that we have right here is just your displacement. Nasolve na ba natin kanina yung displacement value natin? Opo, yung displacement natin ay 40 meters. So, wala tayong problema. We already were able to solve this one. So, you can see na yung step-by-step na problem solving natin, napakadali na lang siya. This is 40 meters. While the change in time is t sub 2 minus t sub 1. Remember that the movement of the car is from 0 to 10 seconds. So here, we can just input the values that we'll be having. This is 40 meters over 10 minus 0 seconds. So the average velocity is 40 over 10 is 4 meters per second. This is the average velocity of the car from 0 to 10 seconds. So I hope you can see this in the reading material kasi yan naman yung pasunod-sunod niya. Please use this video as a guide in reading your reading materials because there are some errors in the reading materials. Pero minimal errors lang naman yun, like yung numerical value, but the final answers and the process are still correct. Okay, so this is how you solve your average velocity. Next is for your average acceleration. For your average acceleration, it's still the same with average velocity, a bar. Remember that the acceleration is change in velocity over change in time. So, change in v over change in t pa rin naman siya kasi average yung kinukuha natin. This is just v sub 2 minus v sub 1 over t sub 2 minus t sub 1. Now, when we say about the velocity, ang gagamitin natin is velocity function. Now, most of the time, since ang akala kang iba, acceleration, ang iba dito, this is the common error. Acceleration kasi, sir, so acceleration yung gagamitin ko. Mali. Remember that when we talk about acceleration, is the change in velocity over change in time. Pag ginawa mo acceleration over time, jerk na yung kinukuha mong value. So, make sure that you don't do this error. Okay? So, the time that we have is from 0 to 10 seconds pa rin. Right? The time that we have here is from 0 to 3 seconds. Now, please take note of the questions kasi sometimes the time will be different from each problem. However, it will still give you the same answer and same process. Pag hindi sinabi yung time, you assume that it's from rest and then from the time interval given. But if it's stated na from 0 to 3 seconds or from 0 to 4 seconds, you follow that one. Okay? Here, in this problem, walang sinabi. So we go back to the initial problem which is from rest to 10 seconds. But dito, sinabi dito na from 0 to negative from 0 to 3 seconds yung time na kinukuha natin. So, let's first solve for the velocity. Remember that the velocity function is this one. So, ang mangyayari, v of t, so yung time natin, time 1 is 0, time 2 is 3. Okay? So, ang mangyayari, 3 yung lalagay natin dito sa loob, 0 naman yung lalagay natin dito sa loob. So, this is 3 times 3 squared minus 30 times 3 plus 54. This is your v sub 2 minus the value of let's use a different color, minus the value of 3 times 0 squared minus 30 times 0 plus 54. Okay. Since this is just 0, 0 to, 0 to. Remember that this is negative. So, ililipat natin yung negative dito, multiply, and then negative. So, negative 54 yung lalabas dito. If it's negative 54, and this is positive 54, this value become 0 as well, right? So, meron ka lang natitira na value dito, nasa taas ay 3 times 3 squared minus 30 times 3 over, of course, your time, wala pa yung time natin, 3 over 0. So, going back to our formula that we have, you'll be solving this one, negative 63 over 3. So, your acceleration or average acceleration is negative 21 meters per second squared. This is your average acceleration from 0 to 3 seconds. Okay, so this is how you solve these problems. Ayan. So, halos na-solve natin yung number 1, number 2, number 3, and then until number 8. So, you can see napakadali lang naman siya as long as you have the values that you have. As long as you have the values or the values of the function. Okay. If you have questions regarding this problem solving, this will be thoroughly discussed during your synchronous session. But as you can see, this is a guide for you when you read your reading material. Okay? So, pakibasa na lang yung may common mistakes and then mga clue in solving for this one because this one is very, very easy. At the same time, yung sinasabi lang natin, the derivative is of the displacement is velocity, and then derivative of velocity is acceleration. To go back, you can just use integration. To go back to displacement, you can just use integration. Okay? So, it's a step-by-step process. So, by next meeting, we'll be solving for these problems and then other problems involved.